Hi, everyone. Thanks for joining us today for our third installment of the Pro Lightning Talk and Virtual Lab series. Today, we're talking about the automotive industry. And if you joined yesterday, we actually talked with Jason Lichtman about how to design parts using generative in Autodesk Fusion 360. Today, we're actually going to hear from one of our amazing MakerBot customers about the automotive company that he founded, built from the ground up, and how he's using 3D printers to bring hypercars to market. But first, before we intro him and bring him in, I do want to mention that if you have any questions during the talk here, be sure and hit that question and that Q&A tab and drop your question in, and we will get to as many of those questions as we can at the end. And this is actually going to be a really unique talk. We're not going to use slides. Our guest is actually going to give us a full-on tour of his facility, which I think is going to be really cool. So with that, I want to introduce our speaker today, Arash Farboud. Arash is an entrepreneur, and he's the founder of Arash Motor Company, a sports car manufacturer in the UK. And if you're not familiar with them, I will just say that they make some of the most beautiful high-performance supercars, and I believe their flagship AF10 will set you back about 1.2 million British pounds. Arash, thanks for joining us today, and we're super excited to have you.
My pleasure. Welcome to Arash Motor Company, and thanks for the invite, MakerBot, to Shauna and Alejandra. I'll start off downstairs and explain the history of how the process has gone with the car company over the years, from the types of materials we've used, from steels and aluminium honeycombs to carbon fibers, and now the use of 3D printing for small parts to quite large parts we're doing now. So the first car we made was made out of a carbon fiber body, and we didn't have many sort of light decorations on the front. So I'm just going to talk to you about one of the details that we've really emphasized and worked on for 3D printing. Over time, we moved to a molding, less decoration, but functionality was still there, moving on to a machined parts over here. Which we really wanted to move to 3D printing because these parts are heavy, they're expensive, they take time to make, and they require finishing on top of it. So over the years, we've moved from the GT cars, the GTS, to AF10, our current hypercar, adding more and more 3D printing pieces to speed up our manufacturing process. And when I say manufacturing, really we're prototype guys, so ones and twos is production for us. So trying to get something physical in your hand to check its fitment and finish and weight and how it joins together with another part is super critical for us. So the MakerBot Rep 2 that we bought, I'll show you upstairs shortly, was really helpful to explain to our engineers and ourselves how things interconnect and how they look physically rather than just a CAD model on the screen. So after we've moved from these phases of manufacturing process, I can show you some of the parts that are actually on one of our production cars. So we're in the assembly area of our amazing facility. Here we've got a part very, very useful, which is a 3D printed light component that is actually made out of PLA, and it's been spray painted as well to give it the metallic look, and all these are individual LEDs. And it was faster and more efficient for us to do it that way than machining in aluminium, which is quite heavy, quite cold, and has a conductive issue when doing the electronics behind it. One of the other pieces that we did on this particular car for AF8 is the rear light ring. So this is actually made out of PLA. It's not ABS, but it's been painted, and it's got a really great finish on it. And it really does show you that you don't have to go to machined aluminium. And this was done a few years back, but this gave us the insight to try and add more and more pieces onto our cars to make things a lot quicker in construction. So the bracketry on this car to hold the bodywork down, that's wrapped carbon fiber over PLA parts. Even an air duct like this we've managed to use a 3D printed part to mount our air mass flow sensor. So we can switch it from there to there if we wanted to, depending on what we want to try out. Some of the other components inside the interior of the car, we experimented with 3D printing, such as door handle surrounds, air duct parts, air conditioning components, and some of the air vents on the top of the dashboard. We were playing around with those and 3D printing them. There's a whole host of bracketry and parts in our drawers that we've tried using our MakerBot 2. We'll go upstairs now, and I can explain some of the next steps we did over the years of how to use our MakerBot and experimenting with different materials. Down here is our showroom. Oh, before we go, there's one other thing I can show you. So over here we've got the assembly of carbon fibre. If you come with Scott's doing amazing camera work here today. We won't go inside the clean room, but in here you can see the stages of building that takes so long to do, but we have to do it because these parts are very structural. So these are parts of the chassis that we're building at the moment. So left-hand front bulkhead, floors, side panels. These are made using traditional processes of machining, tooling the molds in carbon fiber, and then trying to make a part with multiple layers. But what we're actually experimenting with today is making the rear portion of the car. This is our new electric EV hypercar. We're trying to experiment with making large structures in an ABS plastic, inserting metal inserts, trying to 3D print them as well, and then wrapping them in carbon fiber. So this is quite a lab for us, this room, for experimenting with really high performance componentry. So today we're moving towards a very advanced carbon monocoque, battery casing using new techniques of 3D printing for cooling, cases that are made out of thermally stable and fire resistant materials for battery boxes, motor casings as well. So some of the motor casings make sense for us to 3D print them, then take a mold in carbon fiber and make a part. And we're doing that on our Z18. Sadly, I don't have my Z18 at the factory because I do a lot of printing at home. So it's in my bedroom, which is a bit weird, but us 3D printing guys like this sort of stuff. Anyway, upstairs I can show you the 3D printer. I've been using a lot of development, which is a Rec 2. So we're moving downstairs to upstairs, so showroom to design studio. I can give you a sneak peek also of what our new hypercar is going to look like. And here's an amazing 3D printed in PLA model of our new EV hypercar. It's an older shape, but we did this as efficiently as we possibly could without going to a traditional mold, show car or model maker as you find in the Formula One industry. This was printed in 9 pieces, glued together, and then painted in my garage, I must add, because I want to make a mess over here. And then all the parts, additional like the wheels and the brakes and the calipers, were all 3D printed as well and glued on. And this is a brilliant thing for our suppliers, our customers to see as we move towards manufacturing a real hypercar. On the screen behind us, we have got the AF10, which you can find out some more information about it. This car is actually in the game Asphalt 8. It's still the fastest car in the game, where we developed a V8 supercharged 4 electric motors, compact dynamics, and a battery pack, which takes the car from 0 to 60 in under 2 seconds, and top speeds that are large and fabulous. So, from this amazing model, we began to get some kind of confidence that we could do things that we never thought we could do using just standard PLA. So from that point on, we tried experimenting with more and more parts, and we started making 1/5 scale model parts. So these parts here are for our 1/5 scale wind tunnel model, and there's a rear wing that we made out of PLA This is a door handle part as well. And you know what? We're going to use this on our real car because it's not going to be very much different from an injection molding in ABS plastic on a Z18 printer. This part here is to check that the hub and bearing assembly fits perfectly before we go on to either 3D print this in titanium or machine it out of high quality aluminium. But this allows us to check all our sensor points before we commit to making the bit. Plus, it's really cool to show off to our suppliers and customers and partners. This is the substrate for our front lights for our new hypercar as well. It was great to try it out on some PLAs to see how it would look and how we mount the 4 main light beams and the 2 headlight beams. And this is also really cool. I made these on the Rep 2 over here. That's a small wishbone to go on our 1/5 scale wind tunnel model. And then there's the full scale version, which we did on the Z18. Again, in PLA, it's not even ABS, but it does allow us to check the bearings, the bushes, and gives an overall feel of what it's going to look like. If I can make that in another material and then wrap it in carbon, that's kind of what we're working on at the moment. And then if we use the same process with the Fusion software that Jason was explaining in the last lightning talk to make it a little bit more organic, then we're going somewhere. So it's pretty exciting times for us to try and use these sort of things. This part here is the front disc hub that goes on our carbon ceramic disc. We printed it in 1:1 in PLA, and again, this is the 1/5 scale model. So this allows us to check fitments, check the hub. It's quite cool as well. So it all comes apart like on the real thing. And for us guys in the model making world and making wind tunnel stuff and making scale models, it's been a real eye-opener to allow us to try different things. Over here, we've got the trusty Rep 2, which I did all my 3D printing on. I got it a few years back, and that's how I got my relationship going with MakerBot. I apologize, I don't have my Z18 here. It's at home, as I was explaining beforehand. And you can see how we printed things from little hubs to these are assemblies. They've just been put on here. But yeah, this is using standard PLA. The new MakerBot machines are a lot more advanced, obviously, and they're a lot more easy to maintain. Over the years, I became quite experienced at stripping apart the head and change the fans and the extrusion points and the nozzles, but you don't really need to do that anymore. It's really easy to manage. So that really gives a background to how we're doing things over here and what are we making out of the parts that we can put on a Z18 or a Rep 2. It gives you an insight on how much trying out you can do. So we wanted to check that the wheel on our show car looked right before we added any other details to it or added carbon fiber elements, or in fact turned it into a carbon fiber wheel. So this gives a really great insight to trying things out. You can see more wishbones, air ducts, which we make to try out. This is a really cool part that we made, which is to show where the heater element goes in for our air conditioning unit. And the good thing is we didn't want to use this anymore because we changed our air conditioning box to a much more efficient system because most of our stuff is EV related. So didn't have to invest in any tooling. We tried it in PLA, don't need it anymore, throw it away or keep it on the shelf as we've done over here. This is an exciting step for us as well. So this is our older AF10 chassis. Now we're moving to a 2-piece monocoque. So you saw in the clean room over there that we're making some of the parts with a very complex, expensive process of machining, tooling, block, making carbon fiber molds of carbon materials, which is a 181. So it's 10 layers of carbon using very skilled laminators. We're trying to move to a 3D printed machine process where we'd make parts of the chassis in a 3D printed way. It's lighter. You're only using material in a deposition or printing spaghetti, as I call it, and then you don't have to machine out stuff and throw stuff away. So it's much faster, more angles can be achieved, and when we saw the fusion system yesterday, it can be a more organic shape. Because at the end of the day, organic structures are always going to be the most efficient. And we have a lot to learn from that, but we've not been able to do as much as we hoped to, because we have to use a machine that cuts or hands that lay into a two-dimensional process. So this is a really good start of the development work we're doing now to make complete chassis and body panels as well. So there you go, Sean. I hope that helps explain what we're doing, and thanks for inviting me over. And I don't know what else you'd like me to discuss. You can ask me some more questions.
I've got. First off, I want to thank you for that tour. I think everybody would agree your facility looks amazing there, and the cars and the prints are super impressive. I've got a bunch of questions for you, so I'm going to ask you to stick around a little longer. So first off, first question, how long have you guys been around as a company, and kind of where did you start and where are you now? And I guess who are your customers, and like
so we're actually celebrating our 20th anniversary. So I didn't explain at the beginning, I should have done maybe earlier on. So this has been, in the nicest possible way, a giant hobby and a privilege to do what I'm doing. And we don't have that many customers. So we are very choosy who we sell these cars to, because they are extremely complicated to make. They're very handmade, they're very dangerous. So we don't have a huge number of customers at the moment. I think we've sold in total, over the total history of 20 years, I think it's 86 cars. I think it's about 86 vehicles. So there's 86 masterpieces, as we call them, around the world, from Taiwan to the Middle East, to England, Germany, and France. And hopefully one day we'll try and get all these fantastic owners to come together to celebrate the Arash products that they've got associated with. And they probably haven't been able to engage with us that easily, but now we're going to make more effort for it. As I said, it was really a giant hobby that I was inspired by the Le Mans racing cars. I went to France to see the 24-hour race, wanted a sports car for myself. I couldn't really afford one, so I made one in a shed, and I made it out of foam with my own hands. And it was it was fun learning about how you do things and could you do it. And you know what? I did. And the white car you saw downstairs, it did the Parade de Pelosse in Le Mans. It went on the Gumball Rally twice. It went to all sorts of events. It was joyous for us. So from that point, a hobby turned into a bit of a business, because I have other responsibilities historically in manufacturing. So I had to do a bit of both. And then celebrating our 20th anniversary, my focus is quite more. My focus is more onto the car company, and with the EV systems happening, I'm having to do a bit of both. So not only are we developing process to make cars, or machines to make machines, we're having to develop the EV systems, the batteries, the motors, the inverters, the DC converters, the way the batteries are put together in order to make our car. And it's become more of a draw with this side of the business, rather than the other side of the business I've had a responsibility over, which is pharmaceutical, medical, consumable packaging for hospitals, which they have learned a lot from myself in this facility on how to mass produce millions of parts. And I think those steps will link together. But today, we're focusing on delivering our amazing hypercar, which has got some great stats on it. We'll be revealing that over the next few weeks, showing how the motors are made and really how the processes are put together to make such a high performance complex thing. And we don't really have a choice other than to push the boundaries in terms of manufacturing and process. Because if we do go down a traditional process, it's not going to work out in terms of supply chain, because we like ones and twos. It's too slow and it's too expensive. So we're having to reinvent the wheel all the time. And what we do tend to find is when we try a different thing, it may not be 100% the first time around, by go 2, 3 or 4, it's 10 times better than what we originally started. It's because we're having to always think differently to make something perform and become physical for us, as you see in some of the parts today. So that gives a little bit of background where I've come from. And
yeah, no, it's a really neat story. I mean, it's incredible. I mean, yeah, these are true works of art, and you know, it's you guys are basically hand building these one at a time, and it's a privilege, I guess, for the buyers to get these, because there are just not that many in the world to be had. So that's really neat. My next question was about kind of the team and the process there. What, you know, if you could take us from kind of start to end of like a car, and maybe focus in a little bit on when does like 3D printing come into play in that process of building a car, you know, from the start. Like, are you, you know, starting with sketches and then kind of moving your way up through CAD and so on and so forth?
well, whatever that can be injection molded, we would 3D print. Whatever we want to show as an interior part or a non-high performance structural part, we'll 3D print now. Whatever we want to demonstrate in terms of a scale model or a wind tunnel model or a structural checking thing, that's where it's coming in. So does that answer that question? Did I say that wrong? Or
yeah, I guess. And then like, yeah, so that's actually a good point there. It sounds like, I mean, you've shown some scale models there, some kind of desktop ones. I don't know, is that kind of part of your process for every car that you guys put out? And how many parts are you printing, or how many parts go into that? Or is it just kind of like the concept, the shape, and then when you get bigger, you know what I mean?
Yeah.
Like, what are the steps in the process?
Right. Okay. So most of the steps are on CAD. So we use SolidWorks here. We have a couple of seats of SolidWorks, and so myself and the designer will try things out. And once we've got it to where we think it's correct, we'll go, yeah, just put it on the MakerBot. We'll print it out and we'll look at it. You know, we'll go, okay, that's great. Okay, that works. And oh, you could probably check its torsional strength just from a 3D print in PLA with, you know, it's got honeycomb filler in this, and you get a quick understanding. I think that's really the fastest way of doing things. We might 3D print something and go, oh my gosh, it's 2 millimeters out here, or that clashes here. How on earth did we get that wrong? And then we'll print it again. Our challenge really is, how do you print something like this without too much structures or fillers in them? So that's always, we're quite experienced at it now. So we know that we print it like that. We don't print it like that because it will fill it up, or we take an understanding of where it's not going to be such a fine print, and we just work around it. So those are the things that you learn over the years of how to have a successful job done, and also using the latest machines. You're not having so many issues of filament failures or waking up in the morning and finding a big pile of spaghetti or nothing on your print bed. So normally it takes us, first time it's done. So it's first time, but you know, something like this, I think we made 2. Yeah. So it wasn't the 3D printer that got it wrong. It was the pitch circle distance of these holes were incorrect. So it was just, I think it was like 3 degrees out. You can't quite see it. So we made one and we went, hang on, that hub doesn't fit this. Was it the 3D printing? Was the CAD modeling? It turned out it was the CAD model to the hub. So we made another one and then we checked it. It was like, yeah, okay. So it's not always the process to get the 3D printing done. It's the process of CAD to qualify what you're doing as well. So normally, today, we're pretty good. It's first time lucky. But we've had so many years of experience of trying things out.
Gotcha.
But that's not what changes. It's it's first time lucky. Yeah, brilliant. We made the bit. Yeah, the sensors changed. Oh, great. Oh, well, let's try do another print. Or it's worse if you start tooling in carbon and then make a carbon part with honeycombs in it, and it's no good. That's fine if you're a big corporation or a Formula One team or an outfit in LMP. We can't do that because we don't get paid by TV viewings, huge sponsors. So we have to do everything as efficiently as we can. We try and get it 1.5 times right. I'd say first time lucky, probably a little bit 50% error, but yeah, 1.5 scale would probably be how we try and do it over here.
Makes sense. I guess what percentage of the parts that go on the car are you designing in-house versus parts that you're using off the shelf? Because I mean, I'm looking at all kinds of parts that you guys are designing and printing and then fabricating on a carbon fiber, or maybe machining, or just putting the printed part on. Are you, what's that breakdown like for custom parts? I mean,
because we're making things EV, so we've kind of eliminated the petrol engine process. So we did a hybrid, petrol engine plus electric motors. It's immensely complicated, a lot of heat issues going on and gearbox issues. It didn't make any sense. The petrol engine was starting to hinder the performance and the elegance of what we do. So I would say 98% of the parts now for our car are either in-house made or a part subcontracted to be made for us to be used, or a process. So take, for example, the wishbone. We haven't decided today whether this will be made in a carbon fiber structure with structures inside it that are metallic, or it will be 3D printed in titanium. We'll find out very soon. That would be classified as an in-house part, really. So when it comes to EV components like batteries, motors, inverters, DC-DC converters, these things do not exist today for the level of performance that we're working on. And even if they did exist, we would have to be at a huge corporation that buys thousands of parts that warrants the investment for companies to do that. Not only that, the processes of making electrification is changing so rapidly. It's almost like mobile phones, that it makes no sense to use an off-the-shelf component. So when it comes to interior components especially, they're quite organic now. They have small intricacies in them. So that's where the 3D printed stuff comes in, very useful. I would say that, yeah, it's getting to like 3% of the car is off the shelf. We're evolving, even the wheels, they're moving away from something off the shelf. The carbon ceramic disc is still with 2 companies that we use at the moment. The rest of it really is, okay, the glass, we don't do glass in here. We use a UK company and an Italian company we use Pilkington for some parts and Isoclima for some of the other parts. It's getting less and less and less. So the more we can do in-house, the better. In fact, if we could 3D print body panels and chassis, which, let's face it, this is where the industry is moving towards, we want to do that because you're not reliant on transport costs, negotiations with suppliers, negotiations on quantities. You kind of just want to press play. It appears. You've done the FDA analysis through software. You're just validating it in a process, I don't know, a crash test or a wind tunnel test. So yeah, that's kind of where we want to go. And as the electrification autonomous vehicle market is starting to change, then you'll probably find more sort of sub companies making parts for the bigger companies or making complete cars using this process that we're probably pioneering. But for the time being, for making 10, 15 cars a year that are super, super high performance, we're at 98% internally made. We have no choice. This is the way it is for us in this sector.
Gotcha. When you guys you got the replicator too a while ago.
Yeah.
Obviously, you've been around for a while before that. So, what made you decide to get a 3D printer? And then I kind of want to know like what was like a part that you printed that was like, wow, like, we could I didn't think we could print this, but we did, and it actually kind of like clicked because all the parts that you guys print are amazing. Now it looks like there's almost like nothing you won't try, but I wonder if there was.
Yeah, the Rep 2 was a starting point. We made, I don't have it here, we made a little bowl for the medical company as well. We made it out of clear filament, it looked pretty good. We thought, oh, okay, that's really good. And we started making brackets. But I think the big game changer was when we made the scale model a little while back for the new EV hypercar. And that was like, oh, okay, we could do a lot here. And that's when we invested in the Z18. The Z18, the bed's bigger and it's taller, so we could make structures as big as this. But really now at the point where we're going, we need a real big bed to make chassis components, body panels, larger air ducts, wheel arch liners. We need to move to ABS plastic so they can cure at 120 degrees rather than the 60, 70 degrees for PLAs. So we can use these parts. So yeah, I think the game changer was the scale model. We make cars, so it's nice to see a scale model. Moving to, actually, we want to make chassis bits, and we want to make interior bits, and we want to make structures that really aren't seen in the car, but we see them and our customers see them when they're being manufactured. So can we make them in a much more efficient process? And it really is happening today because we don't have a reliance on our suppliers to deliver because our volumes are so slow. So we don't have a pressure from certain suppliers to get things done. So we can be flexible and say, actually, we don't need to buy 1,000 aluminium tubes to do the cooling for the air conditioning unit or the cooling package for the petrol engines historically. So we can say, well, actually, we can 3D print it in a wash-away material, wrap it in carbon, heat it up when it's cured, and pull out the internal, and there's your parts. And hey, you really need 3 of them. The engine design might change. Well, now the electric motor design might change. So it's a good thing we didn't invest in all that tooling. And tooling is the word that we we use with an element of concern, because tooling normally means massive design, cost, installation, machinery, support machinery. We're trying to avoid that. And I think a lot of companies are learning from us to try different techniques, to not go down a traditional process. And that, of course, affects your bottom line, your output, your speed, your skill set changes. So instead of using a certain skill set for making very, very cumbersome or slow process parts, we're using that skill set that's trained. So the people that work here are now doing stuff they never thought they could do, which is CAD modeling or designing things or making stuff out of materials they never used to. So they used to be historically a welder or a pattern maker or a mechanic. Now they find themselves trying out different things in terms of CAD packages, printing, carbon fiber techniques, stressing stuff, experimenting with stuff. And their mindset now is also being affected by, well, we don't use a petrol engine so much now. We work with motors, and understanding what volts are and how that interfaces with cars, because everything has become solid state for us. There's only a few moving parts in our car now. So yeah, it has affected the design process greatly.
Does that simplify, like when things move to electric, does that make the car more simpler, or does it make it more complex in your opinion?
I think there's certain improvements that we made in terms of complexity reduction, which obviously we're seeing with other electric car companies. So instead of having multiple gearboxes, multiple exhausts, multiple engines, multiple cooling systems, it's all shrunk down. So we're able to produce more power, more consistent power with a fraction of the weight, and less componentry. So we're now moving away from quite large boxes that do stuff for electrification to small boxes and less boxes.
Mhm.
The complexity has shifted from multiple known parts, so like a fuel pump, fuel tank, and cooling for that, and filters. We don't have that complexity anymore, so we're now concentrating on the cooling of the battery packs and systems around the motors. So the mindset of complexity has moved from known stuff, which we've been trying to push on the limit, like all the other big car companies are doing. So the big OEMs will be concentrating on making their pistons lighter, the conrods lighter, and their rotating masses lighter and more balanced and faster. We don't need to worry about that now. So we're more interested in how to make our motor lighter, our rotor lighter inside the motor, the cooling of it better. So that complexity and knowledge is being pushed into the unknown bits. So yes, we've removed lots of complexity on what we used to do as a small car company. I can't begin to understand what it's like for a large corporation making saloon cars, sedan cars, to really concentrating on the bits that matter for us. So bits that matter for us are the beautification of parts, the interiors, the styling, reliability, in terms of powertrain. So powertrain is becoming more wonderfully reliable for us, because we're dealing with volts, so battery storage and motors using polar motion.
Mhm.
So that's a great thing for us.
Nice. Yeah, I can imagine. So you can kind of focus on different things.
Yeah.
Maybe fewer drivetrain components, and
Yes. Concentrating more on how to make the drivetrain more efficient on the small number of parts
Mhm.
is easier for us. Historically, we'd have a big V8 engine, just bigger turbos on it, and more cooling, and more fuel systems, and more heat management, and more air conditioning, air cooling, and gearbox management and gearbox calibration. We're not really concentrating on that so much now. We're concentrating on making the motors faster, lighter, cool, more power, more consistent, better peak powers, battery packs that are more elegant in construction, the positioning of them, crash safety. The mindset's changed. It's steam engine to petrol engine, I suppose, or I don't know, making buildings out of bricks and mortars now moved to steel. Well, I'm just looking around our building. This is steel frame plus very insulative cladding. So the mindset's changed to, well, do we need bricklayers? Do we need lots of ladders? No, we want to efficiently put cladding on a building and use steel structures to do the basic requirement. And hey, it's more efficient. It keeps buildings cooler and warmer in winter, and it's faster to put up, and it lasts a lot longer, and it's probably more fire retardant as well. So it's the same mindset car company.
Cool. I've seen a number of questions pop up about your use of PLA. Some people are surprised by that. People are wondering what you like about PLA, if there are advantages of that over another material. And somebody specifically asked about roughness
PLA.
when it comes to wind tunnel analysis.
Wind tunnel analysis. What's the benefit of making these cars for wind tunnel analysis?
No, they were asking if PLA, if like the roughness of like ridge lines is an issue, or do you guys paint them, or
we paint them, or we wrap them, sand them down. PLA is pretty easy to sand down. I've seen some people dipping them in a material that makes it really soft. We like PLA because it's available. I can order it. ABS is nicer, but you have to have a heated chamber in process. It's not a bad material for prototyping, checking stuff. If you can go to other materials, but other machines are more more accustomed to that we're learning about ourselves over here. So really, we were stuck with MakerBot because that's what we use here, and we just use the materials that are available. Of course, there's the new MakerBot machines that are around now, such as the lab. I can't remember their name. Sorry. Method, that's the one I was trying to get to. These can use different materials, but the PLA seems to be working out fine for us. Just don't get them too hot. That's it.
Right. Yeah. On that note, I mean, what would you, have you guys looked into, or I guess, would you be interested in using some other materials if you had, if you had the printer, and then if you had a method, would you be interested in trying out like some of the carbon fiber composite?
Yeah, absolutely. So we want to try the carbon parts with the method. We're trying to see whether we can make hard pads for inserts inside our carbon monocoques or body panels. So historically, what we had to do is machine an aluminium piece and tap and die a metal helicoil into them to be then put inside a carbon fiber part that's in a mold and cured and popped out. So what we're working on today is hopefully using the method to print parts rather than having to be sent off to be machined, and then put a helicoil in there, and then put that into our carbon mold, produced part. That would be ideal. There are some brackets that we would like to try out as well. We will try and push them to the limit once we try using the carbon fiber filaments to see how far they can go. And that's just going to be a trial and error thing. Some of it will be tested in lab in terms of pull and twist and shear. But yeah, the more we can do, the better. The bed size is our limiting factor, of course. If we can have a bigger bed size, then we could make more body panels or substrates under body panels. So yeah, we're going to experiment over the next few weeks. You've got to bear in mind that this company has had a little bit of a slowdown because of lockdown, and we've not been able to communicate with our partners as easily because we've been functioning on stuff that's been planned last year, so monocoque and electrical systems and processes that we're involved with today have kind of been on the radar. So now we're trying to swap out those processes and say, well, let's not do that through a traditional process. Let's do that as a 3D print and wrap it, or this as a 3D print in metal, or this as a 3D print in carbon. So these steps, just before we start making it using a traditional process, I'm now putting call outs to a Demon 3D print down in Cambridgeshire, laser lines in Silverstone, 3D Park with KWS, Kieran Sultan's team. I talk to them quite regularly. There's a few great companies that we're just saying, can you try this? Can you do this? What do you reckon? And some of it doesn't make sense. It's either so expensive to do a little widget, or it's not quite going to work out for us. So then we go back to PLA, or we just try, yeah, okay, well, let's try to do a real big structure, rather than going down a machine it in tooling block, make a mold in carbon, make a part in carbon fiber, all the layup books, all the isotropic layers, all the weave. It's such a long, difficult process. And that's, you look at a Formula One team, how many different steps they do to make a single part. That's what we're trying to avoid. So yeah, if I can move towards the method printer to make the parts that it will fit on there, I'm sure MakerBot will make a bigger one, a taller one like a Z18, the better for sure.
I'm going to ask you a huge favor. I would love to take a walk back down to the showroom and look at the cars some more, because I'm sure some other people would too.
Sure, I can give you a little bit of a background to each one of them.
Yeah,
I can talk the AF10. AF10's a really cool one. That's
yeah,
our hypercar.
That'd be
No
awesome.
problem. Follow me.
Yeah. While we're walking down there, did I have a question about you mentioned a bunch of different applications for the 3D printed parts, obviously prototyping, but then some just end up on the car in PLA, some you wrap in carbon fiber. Like, are
Yes.
those, I mean, that's a pretty diverse use of, and creative use of PLA parts.
Essentially, we just need something physical. And to get something physical, it's really hard. You either send it off to a machine shop, which is really expensive, or you hand make something, which is totally inaccurate. I mean, I used to do all of this when I was learning at university and doing model making, and even today with Lego, I love playing with Lego with my kids, and the accuracy is pretty amazing. But when you make it for a car that you want to demonstrate to your clients and customers and suppliers, then the 3D printing stuff is a great step forward. So this particular car, it's got its position on the tabletop. This one is our flagship today. It's got a carbon chassis. It was quite a big step for us to make a chassis like this. You can hear it's made out of multiple layers of carbon fiber, aluminium honeycombs in the middle, and it's like a giant I-beam on either side of a middle beam to make it very stiff and light. This particular car it's been through quite a few iterations of design. So it started off in 2009 with a V8 engine, then it moved to a Judd V10, which is a high revving racing engine, and then it's moved to a V8 supercharged with 4 electric motors. And this actually, this is the last version of our test car, and it has a V12 engine in this one. So this was the precursor to our AF11, which was a V12 with an electric motor on the back of a sequential gearbox. And you can see it's, we had the orange cabling to define that it was electric hybrid. It was a lot of learning to get to this stage. Even the glass on this is actually plastic, so that's from Isoclima. That's the same company that makes the jet canopies. It's got a slight haze on it, so that's the heat and UV protection and tinting. They do a really good job. The door on here is a demonstration of how we were experimenting. That's only 2 layers of 2x2 twill carbon fiber, just to see how low we could go. And it's still standing for the test of time. This car has done a lot of work at Top Gear and test days, and it went on quite a few events. Sadly, this car didn't go up the hill at Goodwood. All the other cars did. But this one didn't quite make it that year. We were trying to experiment with an engine, and the engine wasn't really up to it. That was a V8 engine at the time. So yeah, this is a great history of learning about composites and how to machine stuff and how to make things using traditional processes. The inside of it does have some 3D printed bits, such as the center part for here. There's been wrapped in leather. There's not so many 3D printed parts on display here. Oh, I think this part here was slightly earlier design. Some of the parts in the engine bay are 3D printed amazingly in PLA, and they're still coping with heat. So I think we have a problem around the 400-degree mark. So when we were making the AF8, we were using a lot of 3D printed bracketry near the exhaust. And, we were sitting around 400 degrees temperature, I think, was it 400? No, maybe not as high as that. Maybe 150 to 200. I think it saw peaks of 400 near the catalytic converter. But they still survived, weirdly, because we were wrapping them in aluminium foil. But it got us going. So we were doing testing at Millbrook, and we just printed off these parts to mount the rear wing. The next car along here is GTS. So this is the one we sold quite a few of these over time. This was made in 2004, and it is a car that I think we made 50, 60 of these. I can't remember. I was quite young then when I made this car. This car was a V6 twin turbo, had fiberglass and carbon body, very light. It was a good starting point for sports car manufacturing for me. It was still early days. I was quite young, as I said, didn't really know how to deal with customers at that time. So it was really an explanation to myself of making something and trying to get engagement. But as I've matured, then you become a little bit more confident to speak to customers and say, oh, try this. The GT car over here is the very first car I ever made. Again, made using quite handmade processes of me sanding down a sheet of block of material and laying material on top of that. And then a carbon fiber specialist came over to help me out. And he's quite high up in a Formula One team now. And he just come over and said, oh my goodness, we've still got this car. So it's a 20-year-old car. It's quite a special car. But I said I went to see the Le Mans Racing team do. These chassis.
On inspiration on that car for sure.
Yeah, it was great. It was such a great thing to get involved with. Are there only 3D printed parts on this chassis? No, they've all been taken off. But we would have put mounts on here for the interior, and some parts around the air conditioning unit, but they've been taken off. They're in a drawer. Oh, here you go. There they are. So these are the trusty brackets that we were using, and the exhaust system sits here. But we printed these in 100% PLA, and they still managed to take the heat. And that's PLA. And that part there must be, I don't know, 5 years old. No problem. And I don't think even that's 100%. I think that's at 30, 50% fill. So it's got the honeycomb in there. So yeah, you can really see bits that we were using those days in PLA, which is that's quite cool. I didn't realize they were there. But yeah, that's a nice stage to see this chassis before it. We stopped making AF8s. We moved to the electric hypercar. But yeah, you can see AF8 if you want to. I can talk about that a bit more if you've got time. I can talk about this all day, as you know.
We still got a little bit of time. I mean, I'd love to see another car. I do have a couple questions that have come in here from some of the viewers. So somebody asked, do you use 3D printing in final production as Lost Park has? So I think we've kind of already covered that. You use it for final production parts, mold and for prototyping, right? All three.
Say again, sorry, I missed that.
They were asking if you used it for prototyping or production or mold, as a mold.
A bit of everything. Yeah. So here you can see this is a production part and it works. We've had them on customer cars as well. The bits that hold the light behind it are 3D printed.
Wow.
I think this part here is 3D printed. There is let's see what's on the inside.
What are the post-processing steps that you take after you take it off the printer before you install it on the car?
That's a 3D printed part. It's made in PLA.
Oh wow.
Yeah, can you believe it?
So you just sand it and you paint it, or are there any other steps you have to take?
Not too much. We just sand it lightly, spray it with a bit of filler, primer, and we paint it. That's it.
Wow.
Yeah, that's a really great piece to show.
Incredible.
I don't think I've got anything else here that's too.
Somebody.
You can just paint straight over the top. Just get a reasonable finish on. Sand it down. I mean, you saw the wind tunnel model upstairs, the show car model I did upstairs. Sand down, go down to grays of sandpaper, filler primer, and then a base primer, and then you color and then clear over the top of it. It seems to cope at 60 degrees baking as well. Anything higher than it can squish down, but just make your infills a little bit stronger.
Mm-hmm. Okay. Let's see. Somebody else wanted to know, why did you choose the hypercar market rather than the consumer market?
Good question. Okay, so the hypercar market today is probably the supercar market 10 years ago. So the boundaries changing. So
Yeah.
in say in 2000, the year 2000, 1990s, the number of sports supercars out there were very few. So you'd have, I don't know, the 911 was a sports car, but it's still a hypercar as well in those days because it had the 911 turbo. You had only a couple of models of Ferraris, and Lamborghini only had one V12 version car. So as the finance world changed and affordability started to kick in, population increased, popularity of brands increased, then the bigger car companies started to enter this market. It's quite a big volume of people in it now. So once that market sector is filled in by so many of the bigger players jostling for it, you have to separate away to go into a different market sector that's available to you. Otherwise, you have to move to something else, I don't know, aviation or space or whatever. So the only markets available for us today that makes sense is the hypercar market, which is optimum performance, highest quality, and lowest volumes. So that's the reasoning behind it. I would love to do a big volume car, but if we want to do that as a small company, are you okay, Scott? Scott's looking at me in the eyes. I'm not sure if it's how it's going on my phone. If you want to do a volume thing, then you've got massive marketing budgets to fill in, and tooling and volume and big factories. And I suppose Tesla is the best example of how to change the game now. And they don't use the traditional processes, and their manufacturing is no longer traditional. The componentry is not traditional, and their sales aspects and marketing and how they deal with their customers is no longer traditional. So we're only left with this top echelon of hypercar because that's all that we can make in the volumes that we do. We could do one-off pieces of art, but that's almost classified as that's more doing something for a chosen client of their choice, whereas we're trying to do a model that's fitting with the car company's vision and its future and its resonating future to fit with what they want as well. So try and marry the two rather than being a concept car maker. We're not that.
Right.
So we stay in the hypercar sector for that. I hope that answers that.
Awesome. Yeah, I mean, I think that makes a lot of sense. I feel like it there's not a lot of companies starting any car companies. So like, I mean, it's got to be an incredible challenge, even if it's low volume. I mean, it's incredible what you got to do, and I think I'm very happy you could share this with us today.
My pleasure. I was listening to a presentation last night. A number of car companies that are still around, haven't gone bankrupt or run out of customers. It gets really tough, the car industry today, and we're quite privileged to be 20 years old, manufactured enough parts internally to have enough understanding and evolving with the times. It's quite a phenomenon to get to this stage and seeing what companies have gone and fallen, and this whole notion of making prototypes and turning them into something in slight volume is really challenging.
Definitely. Well, we'll definitely be keeping our eye on you guys, and if the viewers out there want to check out more, they can go to your website, arashmotors.com. Is that right? Okay.
Yeah.
And
follow us on our social media. We've got Instagram, Facebook, Twitter.
There you go.
And YouTube. Oh yes, we're doing YouTube videos now.
Awesome.
Videos are better.
Yeah, I think if anything's clear, it's definitely follow if this content's any indication, because I think this webinar has been a treat for me and the audience. It's definitely a unique one. We've never done a tour like this, like I said before. So yeah, definitely looking forward to that. And want to thank Arash for taking the time to give us this tour. I want to thank all the viewers for joining us today and all the great questions. We weren't able to get to all of them, but we will. We will be following up with people who we didn't answer their question on here. If you do have any other questions for us or Rush, we can definitely share them with him. Just contact us, hello@makerbot.com. And if you want to learn more about our 3D printers, the MakerBot Method series, carbon fiber edition, check out makerbot.com/carbon. And yeah, thanks again for joining us. This is the last episode of our Pro Lightning Talks and Lab series for the year. So we hope everybody enjoyed that. Also, yeah, if you are interested in our 3D printers, go ahead and hit yes on the poll there, and we'll have somebody reach out as well. And we also, one last plug, I promise, we do have a holiday promo going on, of course. So if you do buy a Method series printer, you can get a free Labs Gen 2 experimental extruder that allows you to print in any third-party material. And we've got some really interesting companies like Kimya, Polymaker, and Jabil, to name a few that we're working with. So we'll end it at that. But again, thanks to Arash, thanks to all the viewers, and everybody have a safe and very happy holiday and a wonderful 2021. We'll see you next time.